How does Reynolds number predict fluid flow regimes? Imagine watching water swirl smoothly down a sink or feeling the chaotic rush of water in a fast-moving river. These are different ways fluids flow, and understanding why they behave that way is fascinating. Today, we're going to explore how a simple number called the Reynolds number helps us predict whether fluid will flow smoothly or in a wild, turbulent way. The Reynolds number is a special kind of ratio that compares to forces inside a fluid. One is called inertial force, which pushes the fluid forward and can cause it to become turbulent. The other is viscous force, which is like the fluid's internal friction that keeps it flowing smoothly. When we look at the Reynolds number, we are essentially measuring which of these forces is stronger. To calculate this number, we take the fluid's density, multiply it by the speed of the flow, and then multiply that by a characteristic length, like the diameter of a pipe. We then divide that by the fluid's viscosity, which is how thick or sticky the fluid is. This calculation gives us a number that tells us about the flow behavior. When the Reynolds number is low, viscous forces dominate. This means the fluid moves in neat, layered sheets with little mixing, known as laminar flow. Think of honey slowly pouring out of a jar. As the Reynolds number increases, inertial forces become more important, and the flow can turn chaotic and irregular, creating eddies and swirls. This is called turbulent flow, like the frothy water in a fast stream. There is a specific point called the critical Reynolds number, usually around 2000 to 4000 in pipes, where flow shifts from laminar to turbulent. If the number is below this, the flow stays smooth. If it's above, turbulence takes over. This transition point can vary depending on the situation, but it's a good rule of thumb. Knowing the Reynolds number helps engineers design pipes, airplanes, and hydraulic systems. For example, in pipe systems, it helps predict pressure losses and how much energy is needed to keep the fluid moving. In aerodynamics, it helps predict how air flows over wings, affecting lift and drag. Because the Reynolds number doesn't depend on the size of the system, it allows engineers to use scaled models to test and predict real-world behavior. This makes it easier to design efficient systems without building full-sized prototypes. In short, the Reynolds number is a simple yet powerful tool that predicts how fluids will flow by comparing the forces that push and resist movement. It's a key principle in fluid mechanics that helps us understand and control the behavior of liquids and gases in countless applications.